Hello. Thank you for joining us today as we connect with Research Vessel Falkor and talk with scientists studying submarine volcanoes in the Pacific Ocean near the nation of Tonga. My name is Logan Mock-Bunning, and I'm on the communications team for Schmidt Ocean Institute. We love participation from all of you watching, so please ask questions. You can ask questions on the YouTube chat bar to the right of your screen, or send tweets with the handle @SchmidtOcean or #UnderwaterFire. Please go ahead and post questions now or at any point in this Hangout. We'll be doing our best to answer the questions during a few spots in the presentation, and we have set aside time at the end for additional Q&A. To get things rolling, a bit of background. The Schmidt Ocean Institute was established in 2009 with the goal of advancing the frontiers of ocean research and exploration through technological innovation, operational support, and open sharing of information. Our research vessel Falkor is equipped with cutting-edge technology, including multi-beam sonar and high-performance computing systems. Right now, Falkor has on board a multidisciplinary team, including experts in geology, biology, and chemistry. The leader of this team is Dr. Ken Rubin from the University of Hawaii, Manoa. Thank you for your time, Ken. Would you like to take it from here?
Thanks, Logan. I'm here. My name is Ken. I'm here with Bill. Bill, say hello.
Hello.
Yep, and we're here out on Falkor. We're in the middle of the Pacific Ocean. And I hope you guys are all having a good day wherever you are. It's really warm and it's sunny and it's early in the morning here in our time zone. And we're going to tell you a little bit about what we're doing here at sea, and then hopefully you'll have some questions. And if, as we're talking about something you don't understand, something that I or Bill are talking about, feel free to, if there's a way through the chat, to ask a question. We don't mind stopping in the middle. But otherwise, we have a kind of a short presentation about what we're doing here, and then we will talk to you more. So this expedition is called Volcanic Fire in the Tongan Sea. It's a catchy name that means to sort of excite people about the research that we're doing, which is looking at volcanoes, submarine volcanoes. There are a lot of them all over the planet. In fact, there are more volcanoes in the oceans than there are anywhere else on the planet. And we're here with a group of scientists using a whole bunch of different kinds of tools, making different observations to study a whole group of volcanoes. And we don't expect most of them to be erupting, but we hope that maybe one of them will. And this is a picture of what one of them, the thing is called West Mata. That means, Mata means eye in the Tongan language. That's what it looked like in 2009 when we were here. Oh, yeah, questions already. Let's go.
Okay, the first one is, who was the first person to study volcanoes?
So well, we have some questions already. The first one was, who was the first person to study volcanoes? So people were studying volcanoes way, way back, probably as early as there were people on the planet. People were making observations when they lived near a volcano that erupted, just like they would make observations of the sky or of the sea. And there are some well-known documented cases. For instance, someone named Pliny the Elder, who studied the eruption of Vesuvius in the year AD 79. So that was almost 2,000 years ago. Made some very important observations of an eruption in Italy. And there have been others as well through history. And we call people who study volcanoes volcanologists. Ooh, yeah, that's a great question. How can you tell a mountain from a volcano? So everyone knows what a mountain is, right? It's a tall pile of rock. It's bigger than a hill. It usually has to be some pretty reasonably tall thing. What makes a volcano doesn't even have to be a hill or a pile. Sometimes a volcano is a hole in the ground. But we call something a volcano if it is currently, or at some time in the past, was spitting out gases or rock or little pieces of rock. Yeah, molten. Sometimes molten, sometimes not. And so that's the classification of a classic volcano. There are other kinds of volcanoes. People sometimes talk about like mud volcanoes. But what makes it different from a mountain or a hill is that it's got at least one or more hole in the summit or on the side, and stuff comes out of it. You want to add anything to that, Bill?
Yeah, so volcanoes are mountains that build themselves, basically. So other mountains maybe get pushed up or they're eroded away. So you form a mountain, but volcanoes kind of build themselves. So like if there's a big mountain that's a volcano, that's all built up from stuff that was thrown out of the ground, piled up, and same thing on the seafloor. Oh, wow. So how big was the biggest eruption? So there's a huge range of eruption sizes, from little tiny ones to really enormous ones. And thank goodness we haven't seen an enormous size eruption in historical time. So, in the last 2,000 years. But in the history of the Earth, there have been some really enormous ones that, for example, Yellowstone in Wyoming is actually a giant volcano, and in the past, like hundreds of thousands of years ago, it's had really enormous, like so big that ash that came out of Yellowstone is, there's deposits of it in Kansas. So that kind of gives you an idea of, most of the United States was covered in ash from eruptions from Yellowstone. So if that happened today, it would be really disruptive, you can imagine. But fortunately, they only happen every, hundreds of thousands of years. So it's not likely to happen in our lifetime thing. But yeah, so the biggest eruptions don't happen very often. That's the good news. And the smallest eruptions happen more frequently. Yeah, so the eruptions we're studying here in this area are, small. So, and we're hoping to catch one in the act, but we don't know if we will.
So the question is, what's a lava dome volcano and what's a shield volcano? That's another great question. So a shield volcano is sort of a broad, gentle slope volcano that forms over many, many years by repeated lava flows. And the lava flows are very runny, very fluid. And so the lava flows run a very far distance relative to where they came out of the ground. And that makes a very gently sloped volcano. The volcanoes in Hawaii, like Mauna Loa, which is the largest active volcano on the planet, that's a shield volcano. A lava dome is formed from a lava that's much stickier. We call it more viscous. It's usually a different kind, a composition of magma, something that we call dacite. And what happens with that is it pushes up out of the ground. It forms more slowly, and it makes a much steeper sided mountain. They tend to be much smaller than shield volcanoes in general. And oftentimes you'll see lava domes on top of other volcanoes. There's a lava dome forming on Mount St. Helens in Washington State today, and it's been forming almost continuously since the big eruption that happened there in 1981. Okay, so we have a few slides to go through, and some of them are pictures, some of them have a little bit of text, and they just give you an idea of what we're doing out here. And this is a picture of, it might be a little bit hard to tell, but this is a bunch of debris. This is, it looks like smoke, but this is underwater. So it's actually particles of sulfur that are coming out, and they're very fine particles, so they behave like smoke. And this is molten magma, and it's a skin on a bubble. So there's a bubble shooting out here, and this stuff is going to cool. If we were watching this as a video, it would cool, and then it would fall apart and pile up. And this is one way that submarine volcanoes erupt. They have lots of different ways that they erupt. Can you show us the next? And this is Falkor. Maybe you've already done some studying on the website. This picture's a little bit old. They painted the ship this summer. Now it's blue. In this picture, it's green. And I personally prefer it in blue. I think it looks good. But this is the ship that we're on. And we're somewhere inside here right now. And this ship is owned and operated by Schmidt Ocean Institute. Excellent. And this is where we are. So this is a map of the Pacific Ocean. For those of you who know a little bit of geography, this is North America over here. And we're just seeing the tip of it. This is the bottom tip of something called Baja California. That's part of Mexico. San Diego and Los Angeles are maybe up here. This is New Zealand, another large island nation in this part of the Pacific. I live in Hawaii. Bill lives in Oregon, which is somewhere up here on this map. And this whole area of the Pacific Ocean is called Polynesia. There's Polynesians there. And we are, can you do the arrow, next slide? Yeah, here. We're working in this little circle. So the ship left from the country of Samoa. We're actually working in water that belongs to the country of Tonga. Tonga is a whole bunch of islands that stretch along this area. We left from Samoa, and now we're working sort of right up here where my thumb is. And there are a couple of very small islands around here, but this is a place that's pretty far from land, but there are lots of little islands in this area, and nearly all these islands are volcanoes. They're not all active volcanoes, but they were formed at one time as a volcano. So this one might be a little bit boring for you guys. I'm sorry. This is what we're doing here. And we're studying submarine volcanoes. We want to see how they change. How do they grow? How long do they take to grow? So how do they change over time? How do they erupt? What's that like? We want to look at hot springs, which under the ocean people call hydrothermal vents. And they spit out hot water into the overlying ocean. We want to understand how that forms and how it distributes and what it does to seawater chemistry. And living on the seafloor around these hot springs are a lot of unusual organisms that get their energy, instead of getting their energy from sunlight, like happens in the environments that we all live in normally, these get their energy out of the hot water and the chemicals that are in there. And so we like to see how do things like volcanic eruptions affect what lives there, how long it lives there, how do those things change in time?
So the thing about submarine volcanoes is we know that so like Ken said earlier, most of the volcanoes on Earth are underwater, but it's hard to see through the ocean. So we don't know much about them. So we know there's lots of volcanic activity happening all the time under the oceans, but we can't see it. It's hard to monitor, hard to detect. So it's something that's happening all the time, but we want to learn more about it, how it affects the oceans, how it affects life in the oceans. So that's kind of what this is about, is kind of trying to get at this mysterious, cool process that we know is happening, but is sort of hidden most of the time, and we're trying to investigate it.
Yeah, next one. So this is the tools that we're using. So this expedition's about a month long, and it's split into two parts. And we have some of the people will be different on the expedition from the two parts, and some of the things that we're using on the ship will be different. So one thing we're using is a robot, an autonomous underwater vehicle. Some people call it AUV. And this is something that gets programmed with a set of instructions while it's on the ship. And then it gets dropped over the side, and it swims down to the bottom of the ocean, and it drives a pattern, and it does various things, the things we ask it to do. In our case, we're asking it to map what is on the seabed in very high resolution, and also to take pictures. It also measures some things in the water, so it tells us something about the chemistry of the water. We're also, on this particular first part of the cruise, we have people that are measuring what's in the water itself. And they have an instrument called a CTD. It's kind of technical, stands for conductivity, temperature, and density, but it measures something about the water. And there's other sensors on there too that tell us things like, are there volcanic gases? Are there little particles? How hot is the water? And we track where those things are, and they help tell us where we think the active hydrothermal vents are on the seafloor, and maybe even where eruptions are happening. And then we have a third thing called an ROV, which stands for Remotely Operated Vehicle. And you may already realize that in the marine sciences, we like to use these abbreviations a lot. Sorry about that. But this is another kind of robot. This is a robot that gets sent over, and it's connected to the ship by cable. And there are pilots that drive it and use various grabbers on it to pick up things like rocks and biological specimens. And we sit in a room here on the ship, and we watch with cameras when that's happening. And we'll be using that in a couple of weeks. And when we're using that, the video that's coming out of it will be streaming live on YouTube. So that'll be something to definitely watch if you're able to. So I don't know, Bill, you want to talk about AUVs?
Yeah, so AUVs are these autonomous vehicles. So autonomous means they're not connected to the ship. We put them over the side. They're battery powered. They swim down and do their thing. They have to be smart to know what to do. So this picture on the top is a bunch of different AUVs. They have lots of different shapes. Some are shaped like torpedoes. Some are different. So this is the one we're using called Sentry. It doesn't look like a torpedo. It kind of looks like a lozenge or something, but it's vertical. So it's shaped this way so it can go up and down in the ocean efficiently, and it's got these wings with propellers on them. So this is the vehicle we're using on this leg. And here's pictures of the ROV. So ROV again is remotely operated vehicle. So this is the one that's connected to the ship by a cable. This is the one we'll be using in 2 weeks. So it gets lowered on the cable. It's got 2 arms in the front for taking samples or deploying instruments. It's got lots of cameras and lights. It's got thrusters. So in the lower right here is the control room on the ship here. So it's robotic, so there's no people in here. All the people are on the ship, but we can control this vehicle when it's under the ship down at the end of the cable. And so we send power down to the vehicle, and we see all the video cameras up on the ship, and the pilots here can control the arms and so forth. So we'll be doing that on the next leg of this cruise. CTD. So this is the third tool, the CTD. Here's what it looks like. It's an instrument package. It's got a bunch of bottles on it that we can use to sample the seawater at various depths. And this is the kind of information we can get. So this is like looking at a slice through the ocean. So here the gray is the seafloor, all the blue is the water, and all these red blobs are showing where there's warm water coming out of the seafloor. So this is an example of where we can, if we see this up in the water, we know there's a vent down on the seafloor. And here's some pictures of the kind of life that lives at the hydrothermal vent that Ken was talking about. They get all their energy from the chemicals coming out in these hot spring fluids. So in the upper left are some black smoker vents. Upper right, some snails and crabs. Lower left, some mussels and a fish and some shrimp. Lower right, some barnacles. So all these animals are dependent on, we only see them around these seafloor hot springs because they get all their energy for life from the hot spring fluid. Kind of amazing. Oh yeah. All these animals are in this area where at these submarine volcanoes where we're making these dives. So these are pictures from previous expeditions.
So this is a map of some of the volcanoes that we're studying, and this is what the seafloor looks like. If you were up here on the ship where we are right now, and we're actually sitting over this spot right here. You know, all we see is seawater out there, but underneath us, there are all these landforms, and the ship itself has a sonar system that's able to make these maps. It bounces lots of little beams of sound. They go down, they come back up. The ship measures how long that takes, and they can figure out the shape of the seafloor. And then we go back with the autonomous underwater vehicle, and it drives very close to the seafloor. It makes us a much nicer looking map. But this is the group of volcanoes that we're studying. They're called the Matas. And these names here, Mata Taha, Mata Ua, Mata Tolu, Mata Fa, Mata Nima, Mata Ono, Mata Fitu, that's just the numbers in Tongan. Taha being 1, Fitu being 7. And this is the one that has been the most active in the past. And we're not only studying it, but we're kind of focusing on it. And this just tells you something about how big they are. Some of them are bigger and some of them are smaller. That's the point. Can you go to the next one? This is another picture of the map of those same volcanoes. But now we're using that same sonar data that came from the ship, and we've made a three-dimensional rendering. Okay, and so here we're kind of looking at, this is that same biggest volcano called West Mata. And you can see that these two volcanoes are a lot pointier. There's a little bit of vertical exaggeration. We've made them a little bit taller than normal on purpose. This one's kind of smooth. You can see these are really bumpy and lumpy, and they're really close together. And this is part of what's so interesting about them is how close together they are, but also how different. So, you know, we tend to use something called the metric system in science for our measurements. And so these volcanoes are something like 1.5 kilometers, which is about a mile, to 7.5. This one here is a 7.5 kilometer gap, which is something like about 5 miles. And they're really not very tall. So 450 meters is something like 1,200 feet. So they're small, they're closely spaced, they're all relatively young, but these two are probably younger and more active, which is what makes them sort of taller and bigger. And now this is a picture of West Mata. And the difference here between the previous images that we're looking at is now, this is a combination of data. And this stuff out here, which is kind of smooth, was sonar data collected from the ship. And this stuff, you can see some here, and there's like a little line, and all this stuff is very lumpy and bumpy. That's data that was collected by the autonomous robot, the AUV. And it drives close to the seabed, and it picks up much, much more detail. So we learn all sorts of really interesting things, like the shapes and sizes of individual lava flows. And I have a blow up on the next slide of this little area right here. And this is now looking down on it. That other one was looking sideways. This is now looking down on it. And this is like a spine along the side of the volcano. And over here where the colors are a little bit green, that's a little bit deeper. And here where it's a little bit brown or orange, that's a little bit shallower. And you can see all sorts of cool little features like these little pits and these flat platforms. And these are all volcanic structures. These pits here are, you know, something like maybe 100 feet or a couple hundred feet across. And these formed at various times during the volcano's history. And one of the questions we have is, so how long does it take to make this stuff? And does it happen all at once, or does it happen in stages? And one of the other things that happens when the volcano, it doesn't just erupt. Sometimes it also breaks apart and material slides away, and it leaves sometimes these things they're like a sharp scarp, and material goes down the slope. And all of those things together contribute to the shape that we ultimately see the volcano have. And it's an important part of the process that we're interested in too. About this one?
Yeah, so this is West Mata volcano again, and the different colored areas show places that have changed since the first survey we did here about 10 years ago. So each color is a different time period. So what this is telling us is that this volcano is very active. Every time we come here and we resurvey the seafloor, something's changed. It's due to an eruption. So pretty much every year or every few years, there's some eruptions last long, some are very short. So each time we come, we learn a little bit more about what this volcano is doing. And for example, we got here on this trip a few days ago, and one of the first things we did was collect a new sonar survey over the volcano, and sure enough, there were changes from just a year and a half ago, and so we're focusing in on that.
So this is a map that shows what we knew through 2012. And the next picture is a map that Bill and a lady named Susan put together. Some of these things are the same, like these two lava flows are the same, this landslide is the same. All these ones here that are open yellow circles that aren't filled in, these are new things that happened since 2012. So this ship, Falkor, was here last year, and it drove across the volcano and made a map for us. And what we do is we take one set of data and we subtract it from the other, and we look at what's different. And these little lumps and bumps showed up. And so this is part of what we've been studying. Last night, we just ran the autonomous vehicle over this thing and this thing. And now we have a really cool high-resolution data set. It's still being worked on, or we would show it to you, but it takes a little while to process the data of what these things look like. And there's yet another picture coming up, and this is what Bill was alluding to. So now this is zoomed into the summit of the volcano. When we got here, the very first thing we did 3 or 4 days ago was do a sonar map again, and these two things had formed in the last year or year and a half or so. So we know the volcano is pretty active, and this is color-coded for how thick it is. And so these are in meters, but a 60 meters is almost 200 feet. So that's a, it's a pretty tall pile of volcanic rock. And one of the things that we've been interested in knowing is it still forming? Is it hot? Are gases coming out of it? Are fluids coming out of it? And so we've been running our CTD over it and running the autonomous vehicle over it and having it measure things in the water. And in fact, there are things coming out of them into the water. So this is another style. This is not something we don't know. We haven't been to the seafloor yet, but this is another way that submarine volcanoes erupt. This is West Mata in 2009, and this is a case where it was erupting really violently. Particles are shooting out. So if I showed you a video clip, you would see the water is sucking in here, and it's spitting out little pieces of molten rock. And one of the nice benefits of studying submarine volcanoes is that these particles, they come out with really high velocities. And if this were on land, we wouldn't be able to get very close because these things would be firing at us and it would be very dangerous. But the seawater helps slow them down. So we can get relatively close and we can actually study what's going on here in a way that is hard to do on land. This is another way in which West Mata has erupted in the past. These are two bubbles of gas that are coming out, and they've got a little skin of magma on them. The magma hasn't started to cool yet. What happens, these things would shoot out of the volcano every 10 seconds or so, and then they would cool, and they would break apart, and then they'll pile up a bunch of little pieces down here. A little bit hard to see in this picture, but that's another way that these kind of volcanoes grow. And this is a time lapse of one of these bubbles sort of coming out, getting bigger, 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 breaking. And this is a picture of another way that these volcanoes erupt. These are the kinds of lavas that form. So sometimes they spit out a lot of gas and particles. Sometimes there's just lava flows that flow across the surface, and they can go fast or they can go slow. It depends a little bit on how steep the slope is and how runny the lava is. These types of lavas tend to move relatively slow. And these are also from West Mata volcano from 2009, and this kind of activity is the sort of thing we don't know yet because we haven't been there, that we imagine that young mound that just formed in the last year and a half, maybe it formed from this kind of process. I think that's, this is what the rocks look like. So these are pieces of rock that we collected here in the past, and what I do is you cut them on a saw. It's the same kind of saw that construction workers use to cut tile, like if you have tile in your bathroom. We cut rock on it. I don't know, it might be a little bit hard to see from where you are, but there's little holes. Those are bubbles that were gas bubbles that cooled and were frozen into the magma. And there's also some crystals. This is a kind of an image made. This is a small piece of rock. It's only about 1/10 of an inch, but I've blown it up for you. And we've run a beam of electrons across it. And the electrons make X-rays come out of the rock. And the X-rays tell us about what the bits of the rock are made of. And so these different colors are different minerals, basically. But what you can see in this rock is the black places are the bubbles. There's nothing there. It's just a bubble. Lots of little black bubbles and lots of little crystals. These make these rocks a little bit unusual. We don't usually see rocks with this many crystals in them in submarine volcanoes. I think there might be another rock picture. No. This is a picture of us collecting a lava flow in 2009. This was the first time someone had done this before, and it took a really long time. The pilots, when we're using one of these remotely operated vehicles, they never let the scientists touch anything. We just sit in the back and we ask the pilots to please collect us something, and it takes a lot of skill. It's a very, very difficult thing to learn how to do. And so they were taking this thing and trying to poke it into this part of the lava that's molten. And it was actually pretty hard. And so eventually they did. I think the next slide shows them pulling out a rock. This is a rock it's on that same little pole. They stuck it in, they ripped it out. And we have this and we're studying it. And it's real interesting. It's the first molten lava collected in the deep ocean. And that's what it looks like. And that's a little hole from where the pole went through it. And it might be a little bit hard to tell from where you are, but there's lots of little crystals in it, the same crystals that we saw in those other slides. I think that's the last. Yeah. Yeah, how long do volcanoes erupt? Another excellent question. It depends a lot on the type of volcano. Some volcanoes, they may only erupt for a day. And other volcanoes may erupt for years and years. There's a famous volcano in Hawaii called Kilauea. It's been erupting nearly continuously since 1983. It's had a couple of little breaks, but it's just pouring out lava every day. But a lot of the volcanoes that Bill and I have worked on, they don't erupt for very long. Some of them erupt for maybe a week. Others of them erupt for a month, or, in the case of one that Bill's been working on, he can tell you more, it erupted for nearly most of a decade. West Mata Volcano, we know about it having erupted for maybe about 3 years. So it really depends a lot on the volcano and the eruption. So some volcanoes can have a long eruption, they can have a short eruption. And we don't really know the details of what controls that, what makes it so different from place to place and eruption to eruption.
Why do volcanoes go to sleep? Yeah, that's a good question. Well, it's a little bit related to the previous question of how long volcanoes are up, because generally volcanoes have there's molten rock underneath them that's trying to get out, and it comes up inside the mountain and sits there, and the pressure builds up in that molten rock, and it's sort of like a balloon. So the pressure builds up, and eventually it pops, and the lava comes out. So it so if there's a lot of magma coming up, then the eruptions from that volcano are going to be frequent. And if there's not very much, then it's going to erupt and then go to sleep for several years, and then maybe the pressure builds up and it erupts again. So it kind of depends on what the supply is of magma or molten rock to that particular volcano, is how often it erupts and how long it sleeps in between eruptions. So for example, this West Mata volcano that we're studying here, it must have a pretty high supply of magma, because we know it's been erupting frequently in the last decade. A what? Storm volcano. I don't know.
So this last question was, what is a storm volcano? And we were just sort of asking ourselves, we're not exactly sure what the question refers to, but some volcanoes, when they erupt, they make lightning, called volcanic lightning. And this is an electrical discharge. It's the same sort of phenomenon that happens when there are electrical discharges between clouds and the surface of the earth. But in volcanic plumes, the kinds that erupt very explosively on land, you will get particles that will shoot up very high in the atmosphere, and they also can develop a very strong charge. And during that process, they can discharge and make lightning, and it looks just like a thunderstorm. Yeah, only on land. We've never seen it in a submarine setting. We assume it doesn't happen.
And Ms. Sneksker, it looks like you guys might have some questions. Do you have some questions?
Okay, you ready? Go ahead.
How can you tell there is an underwater volcano?
So the question is sort of, how can we tell if there is an underwater volcano somewhere? And there's several different ways. For some parts of the oceans, the way we can tell that something is a volcano is because when it erupts, it makes little earthquakes. And so parts of the oceans have instruments that can listen for earthquakes, either seismometers or something called hydrophones. And that's one way to tell. Another way is if we see a bump on the seafloor, then it was probably formed as a volcano at some point. And then we go and study it and see, is it an active volcano? Are there gases and fluids coming out of the summit? Do the lava flows look young? So we can't tell just by looking at it. And oftentimes on land, we can tell if something's a volcano, but just by looking at it, we can't necessarily say if it's active or not either, unless it, smoke's coming out of the top.
Miss LaSalle, did you guys have some questions?
Yep. What's your favorite part of your job?
It's muted.
Oh, that's an excellent question. For me, my favorite part of the job is coming out and doing this is what we call field work. So a lot of time we're back in the office and we're poring over the data and the observations that we collect when we come out to a volcano. But this for me is the fun part, where we get to make discoveries and we get to be in an exciting environment and you get to be with your friends, and everything about coming out to the field for me is my favorite part.
Yeah, for me, I love being surprised. So, I was talking about earlier how it's studying these volcanoes underwater that you can't see. Usually it's sort of kind of a mystery, or there's a lot of mystery to it, and we're trying to find answers. And so part of that is when you don't know a lot to begin with, it's easy to get surprised by what you find. And to me, that's a really fun feeling of, discovering something new and it wasn't what you expected, and wow. And then immediately I'm thinking, well, what does that mean? And how does that make sense? And, oh, that's what's happening there. So all those, that's what science really is being curious about something, trying to figure out how to answer the question you have, and then hopefully, finding an answer that's, maybe surprising and interesting and exciting.
Let's try Miss Nexter's class again.
Okay, Coral, go ahead. Really loud.
Why do you study volcanoes?
Volcanoes are cool. So when I was in college, I took some classes in geology. Geology is the study of the earth and its history and how it works, and part of that is volcanoes. And while I was in college, Mount St. Helens erupted. So that's the volcano in Washington State. And I thought that really got my attention. And I knew some people who knew some people, and I got a job working there. And all of a sudden I was flying in a helicopter and working up at Mount St. Helens, and it was still active when I was there. And, I thought that was about the most exciting thing I could think of. And so I just kept doing it because it was fun and interesting and exciting. How about you, Ken?
Yeah, for me, ever since I was a very young kid, so same age as you all, there were two things I really liked. One was going to the beach and going in the ocean, and the other one was volcanoes. And so even though at a young age I didn't know I was going to become a scientist and study volcanoes, I've always liked them. And it was just sort of a natural thing for me that as I got older and I got to decide what it is I want to do, I said I would like to learn more about volcanoes. And so that's just how it happened for me. And I hope for all of you, if there's something that you're interested in, it doesn't matter what it is, keep pursuing that, keep being interested in it, and follow your dreams. If there's something that you want to do and that interests you, stick with it, because it can be really fun and a really rewarding kind of job to be able to work on something that you love.
Let's go with Miss LaSalle's class again. Oh, I'm afraid you're muted. Can you guys unmute yourself? Thank you.
How close can you get to submarine volcanoes?
Yeah, well, excellent question. How close can we get to a submarine volcano? And so with the remotely operated vehicle, the robot, it can get pretty close. It's this distance. And one of the things that it has is a long stick that's like a thermometer that can measure temperatures. And the last time West Mata was erupting, we used that stick, and we would get closer and closer to lava to see how hot it was. And just a few inches away from the surface of the lava, it wasn't very hot. You know, the remotely operated vehicle has various parts on it that are sensitive to heat. Some of it's made out of metal, but there's some plastic and some wires. And conditions can change really quickly at a volcano, so we try to stay at a safe distance when we can. But you know, getting within a few feet of where stuff is coming out of the seafloor, where it's erupting, is something that we can do. We have done it.
Like Ken said earlier, it's different underwater than on land, because on land, you know, volcanoes can be very explosive, and you know, you can't get close to a vent where stuff is coming out because it might kill you. But underwater, partly it's the pressure from all the water above you. That pressure kind of subdues the volcanic activity, the explosions, and also if stuff gets thrown out, it gets slowed down very quickly because water's thicker than air, and also at the bottom of the ocean, the water's cold, and there's so much of it that even though the lava is really hot, there's so much cold water that it cools very quickly. And so that's another reason why we're able to get closer to like a vent where you could never do it on land, but underwater you can get very close and actually see what's happening. So that's part of the cool aspect of working at these submarine volcanoes.
Ms. Schnexner, if you guys would like to unmute and ask a question, we'll do one more from you guys and then one more from Ms. LaSalle after that.
All right, go ahead.
How long have you studied volcanoes?
Let's see. So pretty much since Mount St. Helens erupted. So that's 1980. So that's 35 years. Wow.
I'm not quite as long as him, but maybe about 25 years for me. But still a long time. Yeah.
All right. Do we have one more question from Ms. LaSalle's class?
Have you found any rare rocks or minerals before?
Yeah, so have we found any rare rocks or minerals? And that's an excellent question that you raised, because it turns out that this particular place is erupting a kind of rock. You know, geologists, we like to give everything a name, and the name of this kind of rock is bonanite, and it's very, very rare on Earth. In fact, we've never seen it erupting in modern times. Last time bonanite erupted on Earth was about 2 million years ago. So that's very rare, and it's got a very unusual chemical composition. It makes the rock very, very hot when it erupts. For my own fun, before I lived in Hawaii, I used to like to do mineral collecting, which meant going out into the desert in California or Arizona and going to old mines and looking around at the rocks that they would leave behind. And you could find all sorts of very interesting minerals. I don't know if I've ever found anything particularly rare, but I found some things that are very beautiful and fun for me because I found them.
Well, I wanted to say really quickly before we start to wrap up, I also wanted to thank Exploring by the Seat of Our Pants for getting everyone together. And to say that if we didn't get to some questions, or if you'd like to see extra videos or images of what we've seen, it's www.schmidtocean.org. We're also on Twitter and on Facebook and on Instagram. To wrap things up, I'd like to do something a little bit different, in that it is actually Bill's birthday. And I was hoping that if you guys had time for the classes, if we could all unmute each other and sing happy birthday to Bill before we leave.
Sure.
If that's all right, we've got at least one class into that.
I'd like to do it.
How about Ken? Do you want to start us off?
I'm not much of a singer, but happy birthday.
Happy birthday.
Happy birthday to you. Woo! Don't ask me how it is.
Eat more sugar!
Yay. Well, again, thank you all very much for joining us. Thank you again to Exploring by the Seat of Your Pants. Thank you to the scientists. Thank you to the crew on Falkor. And if anyone has any more questions, please, again, look us up online, www.schmidtocean.org, and hopefully we'll be in touch in the future. Thank you very much.
Bye.
Bye.